All right, guys, welcome. This notes are a little bit different than usual. They're on their own page, not with the practice. This is the first time that's happened, but I don't necessarily always put the notes with the practice. It just kind of depends on the length of everything. And the practice was already 2 pages, so I didn't want to put this on there as well and make it 3. So, and if you were confused about that, this is the notes by itself. It's just 1 page. So we're going to go over these today. It should be a short video. We're going to be talking about length and distance, okay? What is the difference between those two? Length is measuring a line segment, all right? And distance would be measuring the distance, I guess. That's obvious, but it's measuring the distance between the 2 points. So for length, you're actually measuring a segment that's there, and distance, you're measuring an imaginary segment that would exist between 2 points, if that makes sense. But they're the exact same things, okay? So we're just going to go through a couple examples. So find the lengths of the following segments, A, B, all right? So we've got a segment here from A to B, all right? And when you're doing it on a number line like this, it's easy to count, right? So you're starting at -2, go to -1, that's 1, 2, 3, right? So this distance or this length would equal 3. All right, then it says BC, okay? So we can do the same thing. Start at 1, that's 1, 2, 3, 4, 5. So the length of line segment BC is 5. Then the last one says CB, okay? And I put this on here for a reason. So BC and CB, is there any difference between those two, all right? And the answer is no, okay? Because the main reason I put this problem on here is that I wanted you to see that length and distance, regardless of which one you're talking about, can never be negative, all right? That doesn't make any sense, right? Like it has a length of -2 inches. That's not really possible. So direction doesn't matter, all right? Both of these are 5, regardless if you start at 6 and go back to 1 or start at 1 and go to 6, right? It doesn't matter. So length and distance are always positive, all right? So the opposite of that, length/distance, can never be negative, okay? So if you're doing one of these problems and you get a negative number, that should be a warning sign to you that you did something wrong. So now we're going to look on a graph, all right? And a graph isn't as easy, okay? It says find the length of the line segment shown on the graph. Well, why is it not as easy? Because you can't just count, all right, when it's going at a diagonal, okay? You can't just be like 1, 2, 3, 4, right? Because it's not 4, right? It's a little bit more. So we got to think of a different way to do this. And the way that we're going to do this is that we're going to count, okay? But we're going to count the horizontal distance and we're going to look at the vertical distance, all right? So the horizontal distance, that's 4. The vertical distance, that's 1, okay? And what does it seem like we made here, right? It seems like we made a triangle, okay? If you look, I use the same color, maybe not a good idea, but if you look there, we made a triangle, right? And specifically, we made a right triangle, okay? And we have some distance right here, some distance D that we don't know, but we do know 2 of the sides, right? We know 4 and we know 1, and you can actually use a theorem here. Hopefully you know this theorem. You should have been taught it at some point, I think, in middle school, but you should have learned the Pythagorean theorem, right? The Pythagorean theorem says that if you have 2 sides of a right triangle, you can get the third side. It specifically says that a squared plus b squared equals c squared, where c is the hypotenuse and a and b are your 2 sides. So our distance that we're looking for, that's the hypotenuse, okay? And our sides are 4 and 1. So we're going to use the Pythagorean theorem here. We've got 4 squared plus 1 squared equals d squared, all right? So 4 squared, that's 16. 1 squared, that's 1, equals d squared. All right, 16 plus 1, that's 17. And now we need to solve this. So we talked about this, all right, in our solving equations day, way back the first week, all right, the second day. But in order to get rid of an exponent, you have to take a square root, all right? So we're going to take the square root of both sides. Now, this is why we did the simplifying radicals yesterday. If this number here can be simplified, all right, we need to simplify it. Now, can 17 be broken up? No. Okay, 17 is a prime number. It can't be broken up. So you can just leave your answer as the square root of 17. If you want to type that into your calculator and figure out what it is as a decimal, you can. But it's not super necessary. But this is why you can't count, right? There's no way to count the square root of 17 along this line, right? It's impossible. It's a little bit more than 4, right? We know the square root of 16 is 4, so this is a little bit more than 4. I'd probably guess somewhere between 4.1 and 4.2 if you type that into your calculator. So that's how you do the problem if it's not a straight line and you can't count. So here, find the distance between the 2 points on the graph, all right? We can do the same thing here, okay? We're just gonna pretend like, what if there was a line segment here between these two? Okay, now, for both of these examples, we have these little like hash marks here where you can count, but let's say those weren't there, right? What if you just had points and coordinates and nothing else? Could you still do this? Well, the answer is yes, okay? If you look at the coordinates, you know how far it is between them, all right? So you can kind of subtract to figure it out. So if you're starting at -1 and you're ending at 1, right? 1 minus -1 is 2. So that's why this side right here is 2, and you could have got that by counting as well. Up top, all right, we're starting at 1 and we're going to 5. So 5 minus 1 is 4. So we know that this side right there has a length of 2. This side has a length of 4, okay? And we're going to use the Pythagorean theorem again, just like we did before to find our distance, which would be d. So we've got 2 squared plus 4 squared equals d squared. So 2 squared, that's 4. 4 squared is 16, all right? 4 plus 16, that's 20. Now, just like last problem, we're going to take the square root of both sides. And we actually can break up 20, right? We can break up 20 into the square root of 4 times the square root of 5. So the square root of 4 is 2. So we've got 2 radical 5 equals d, right? And that'd be our final answer. So this is length and distance, all right? This is pretty much what you're going to be doing on your practice. Hopefully this made sense to you guys. If you have any questions on this, all right, as always, bring those questions to the Zoom session and we can go over this stuff a little bit more if you need to. But other than that, have a great day.